One last example right here to illustrate our using of the identities and our algebra in order to rewrite these expressions so that one looks like the other. And typically what we would want to do right here is, if we have an expression, the very first thing I'm going to go to, if it's at all possible for me to do so, I would like to rewrite one side of the expression so that it looks like the other. And if I can use some algebra to do that first, I will. Now, unfortunately, the problem that we have at the moment is that we have only expressions in terms where we're adding, but there's no like terms here to add, and multiplying on the right-hand side. So the question might be, well, what could we do? Well, I'm going to take what I consider the more complicated side, the side with the addition sign, and see if I can simplify that into something on the right-hand side. So if there's no algebra present at first, sometimes rewriting our expression so that we use our trigonometric identities is helpful. And I'll note that tangent of x and cotangent of x, well, there's not an exact match between secant of x and cosecant of x, but there is one between sine of x and cosine of x. So let's take that left-hand side here. Tangent of x is the same thing as taking the sine of x divided by the cosine of x. And cotangent of x is the same thing as taking the cosine of x and dividing that by the sine of x. So the only thing I'm going to manipulate over here is the left-hand side of my equation. I'm going to leave the right-hand side of my equation just as is. Secant of x times cosecant of x. Well, actually, I can rewrite that other side. Let's just rewrite this. I mean, we've got it in terms of sine and cosine over here on the left. Let's put it in terms of sine and cosine on the right. We've got 1 over cosine of x for secant of x, and cosecant of x is 1 over sine of x. So now I see there might be a connection. What could I do? Well, if I wanted to add two fractions together, I'd have to get a common denominator. Well, a common denominator right here, our LCD of these two fractions, is cosine of x times sine of x. So that's what I'm going to do. On my left-hand side, I'm going to combine my two fractions over this LCD. So what do I have to do? In the first fraction, I'd have to multiply by sine of x into the numerator and denominator, so that I would get sine squared x divided by sine of x times cosine of x. And in my right fraction over here, I'd have to multiply by cosine of x into the numerator and denominator, giving me cosine squared x divided by sine of x times cosine of x. And again, I am not changing anything on my right-hand side anymore. Well, I suppose I could multiply these together to give me cosine of x times sine of x, all in the denominator of the same fraction. So let's add these two terms together. I've got sine of x squared, square of sine of x, plus the square of cosine of x, all divided by sine of x times the cosine of x. And we're saying that's equal to 1 over cosine of x times sine of x. And right up here in the numerator, there we go. It's a Pythagorean identity trick. We can replace cosine of x plus sine squared x with 1. So we'll get 1 over the sine of x times the cosine of x, set equal to 1 over the cosine of x times the sine of x. Well, lo and behold, that's exactly what we were looking for. Our identity is verified, and so we're done with it. Okay, good luck on your assignments.